In this video, I want to introduce Chapter 8 with probability. So we'll start off with 8a, a review of probability. Let's have a look at a few of the key ideas. So the first dot points are our definitions. So we need to know what a trial is. So a trial is a single experiment such as a single roll of a die. The next term is a sample space. So the sample space is the list of all possible outcomes from an experiment. The example we have here is when we roll a six-sided die, the sample space is 1, 2, 3, 4, 5, 6. The outcome is a possible result of an experiment. An event is the collection of favorable outcomes. And finally, equally likely outcomes are outcomes that have the same chance of occurring. So a good example of this is the chance of flipping a heads or a tails in a coin flip. So the next thing I need to introduce is the scale from 0 to 1, which is generally what we use to describe levels of chance. So using this scale, 0 will represent impossible, whereas 1 will represent certain. That means for an event with an even chance, the probability will be 0.5. As we go further towards 0 to the left side, this will become unlikely. As we go further towards 1, this will become likely. Okay, so let's try some of these examples ourselves. A letter is chosen from the word calculation. Find the probability that the letter is a T. So the first step is to figure out how many letters we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So how many T's do we have? We have 1, only 1 T. So the probability of finding a T will equal to 1 over 11. In B, the probability of finding an A, we need to ask ourselves how many A's do we have? We've got 1, 2. 2A, so the probability of finding an A will equal to 2 over 11. In example C, find the probability that it is not an A. So not an A. So how many letters do we have here which are not A's? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So this will be 9 over 11. Let's have a look at this question. An experiment involves checking second-hand bicycles for faults. Here are the results after checking 100 bicycles. Find the experimental probability that a randomly selected bicycle will have 0 faults. So for this question, you'll notice that the frequencies 10, 32, 45, 9, and 4 will add up to 100. So to find the probability for 0 faults, you need to ask yourself on the column how many have 0 faults. That frequency will be 10. So this will be 10 over 100, which is equivalent to 0.1. So for part B, you're looking at 3 faults. So on our frequency table, 3 faults will be 9. So the probability of 3 faults will be 9 over 100, which is going to be equivalent to 0.09. In C, you're looking at fewer than 3 faults. So fewer than 3 will include 2, 1, and 0. So probability that it is, in this case, less than 3 is going to equal to 10 plus 32 plus 45 divided by 100. So that's the same as 87 over 100, which is going to be equivalent to, in this case, 0.87. And finally, for D, if we're looking for at least 1 fault, that means that we are looking for 1 inclusive, because it says at least. So it's 1, 2, 3, and 4. So the probability of, in this case, greater than or equal to 1 fault is going to be 32 plus 45 plus 9 plus 4 over 100. So this will be equivalent to 90 over 100, which is the same as saying 0.9. So that's it for this video. Hopefully you found it useful, and I'll see you in the next one.